Still. Okay. All right, so this evening, we are going to continue to look at polynomials, but we're going to be looking at the division of polynomials and then the remainder theorem and the factor theorem. Okay. So first of all, let's look at one example. So our first example this evening is going to be x cubed minus 2x squared plus 5x minus 4 divided by x plus 3. Okay. All right, so what we are doing is division of polynomials, okay? So this will be our divisor. This will be our dividend. And then our answer is going to be our quotient. And we may or may not have a remainder, okay? Now, there are two ways to divide polynomials. You can divide them by long division or synthetic division. We're not going to look at long division because the problems that we're going to be working can all be completed using synthetic, okay? All right, so the first thing that you want to do always is to make sure all exponents are accounted for. Okay, if not, you're going to put a 0 as a placeholder. Okay. All right, so what I mean by that is when we look at the polynomial, the highest exponent is 3. When we count backwards, we should have x to the second, x to the first, and then 0. If we're missing an exponent somewhere in here, for example, if this 2x squared was not there and it automatically jumped from x cubed to 5x, then we would have to put a 0 there as a placeholder, and so it would be 0x squared, okay? But in this case, we have everything. I'm sorry. All right, so what we're going to do then is take our divisor. We will always set it equal to 0 and solve for x. So in this case, x is equal to -3. Okay? I'm sorry? 8,3. So we take our -3, put it on the outside, and we create like a little half box, okay? And then all you're going to do is put your coefficients of your variables inside the box. So the coefficient here is 1. Then next we have -2, +5, and then -4. Okay. So again, the number on the outside of the box comes from taking your divisor, setting it equal to 0 and solving for x. So that's where that came from. These numbers are simply our coefficients of our variables. So 1, -2, +5, and -4. Okay. And from here is pretty much just a pattern, a cycle. Okay. We always start by dropping the first number. That's going to happen every single time. So the 1 goes on the outside. And then if we have a number below the line, you're going to multiply and put that number above the line. So here's your pattern. -3 times 1 is -3. It goes above the line or inside the box, however you want to say it. Then if it's inside, we combine these two together. So -2 plus -3 is -5. Again, when we combine this, it's outside the box. So then we multiply again. So -3 times -5 is +15. Inside, so that means we combine these together. So 5 plus 15 is 20, goes outside. We do the same thing again. -3 times 20 is -60. And then we combine. -4 plus -60 is -64. Okay. So these are going to be the coefficients of our new problem. Okay. To determine what our coefficient is, we're going to take these coefficients and put them back with our x's. But when we do that, our first exponent is always going to be 1 less. So you subtract 1, okay? So subtract 1 from the degree or the highest exponent. So we end up with 1x squared minus 5x plus 20. All we're doing is counting backwards. So 2, 1, 0. So that means this -64 will be our remainder. Okay, and so the way that we can write that is plus -64 over x plus 3. This is how you show a remainder. Okay. Okay. All right, so let's put a couple of things together now. So let's talk about it. So here, we just established that our remainder is -64. Since x plus 3, remember that's what we were dividing here, okay? So since x plus 3 does not divide evenly, there is a remainder. That's where we get this from. If it did divide evenly, then we would not have a remainder. And also we know that x plus 3 is not a factor of the dividend. X cubed minus 2x squared plus 5x minus 4. Okay. If we put this in terms that we're used to, let's say 4 into 22. And this is just giving you an example. How many times does 4 go into 22? 5 times. Then we get 5 times 4 is 20. Subtract, we get a remainder of 2, right? So that means that because 4 does not evenly go into 22, we get a remainder of 2. This also means that 4 is not a factor of 22. Factors, if you recall, are numbers that can be divided evenly into that particular number, or numbers that we can multiply together to get this number, okay? So let's look at it with another one. So 4 goes into 20. How many times? 5. 5 times 4 is 20, so our remainder is 0, okay? Because our remainder is 0, that means 4 can evenly go into 20, right? It also means that 4 is a factor of 20, because 4 times 5 is 20. So that's the same thing that we're saying here. When I divided x plus 3 and this polynomial, I received a remainder. So that means x plus 3 cannot evenly go into this. Therefore, x plus 3 is not a factor of this polynomial. Okay? Questions? All right. Let's look at another one. All right, so example 2, we have x cubed minus 2x squared plus 5x minus 4 divided by x minus 1. Okay. All right, so first things first, we make sure all of our exponents are accounted for. So what is our degree or highest exponent? 3. And so we count backwards. 3, 2, 1, 0. So everything is accounted for. What do we do now? Okay. Okay, before that, we have to figure out what's going to go on the outside of that box. So we take the divisor, set it equal to 0. Yes. And then we solve for x. So we add 1 to both sides. We get x is equal to 1. The 1 is what goes on the outside. Okay. All right, so now we pull out our coefficients. What's the first one? Good. Next. And very good, guys. We always begin by what? Good. So this becomes 1, and then we just start our process. So 1 times 1 is 1. Inside, what's -2 and 1? -1. We multiply again because we're on the outside. 1 times -1 is 1. 1 times -1 is -1. Okay. 5 and -1 is 4. And then 1 times 4 is 1 times 4 is 4. Y'all getting like me, jumping ahead. And -4 and 4 is 0. Okay. All right. So what is this quotient? What does it begin with? Okay. So remember, our quotient, our answer will always be 1 less than the degree here. So we subtract 1 from the highest exponent. Okay. Good. So it'll be x squared minus x, good, plus 4. What's our remainder this time? 0. Very good. So thinking about what we did here, we said 4 went into 20 evenly, right, and gave us 5. So that means these two things multiplied together gives us our dividend, what we started with. So the same thing applies here. If this is my answer, and I just want you to understand this, if this is my answer, then that means x squared minus x plus 4 times x minus 1. If I multiply this together, I'm going to get that answer. That's what that means. Okay. All right, so let's talk about a couple things. Okay, what's my remainder here on number 2? Good. So since x minus 1 evenly goes into x cubed minus 2x squared plus 5x minus 4, that means that we have a factor. Very good, with x minus 1. Questions? Okay. Okay, so let's now take this dividend that we just had, x cubed minus 2x squared plus 5x minus 4, and we're going to turn it into a function. Okay, same problem, but we're going to turn it into a function. So that's going to become f of x is equal to x cubed minus 2x squared plus 5x minus 4. And I want you to find f of negative 3 and f of 1. Okay? So what would we do to find f of negative 3? Very good. Wherever we see x, it is now negative 3. So we're going to have negative 3 to the third power minus 2 times negative 3 squared plus 5 times negative 3 minus 4. What do you get? Good. Okay. All right, what about f of 1? Same function. You said you got what? Let's see. 1 cube. Say it again. Sure about that. I got 0. You figure out your mistake? Okay. Okay, so let's take notice of here, when we found f of negative 3, that's this problem right here. Remember, this is our function. We took negative 3, divided, and our remainder was negative 64. Okay. So what we see here is if we evaluate a function at a particular number, whatever the remainder is, whatever our answer is here, when we evaluate it, will be the remainder if we divide that divisor and the dividend. Okay, so if you look here, here was our dividend. This is what we were dividing into. X minus 1 was our divisor. The remainder was 0. Here, when we evaluated f of 1 into that function, the remainder is 0. Okay? Questions there? Yes.
Do you have to do the division part, or can you just plug it in?
Hold that thought for a second, okay? Because it depends. And so this leads us into a theorem, okay? And that's where that's what I wanted you to see. So the remainder theorem tells us if we substitute a value for x, meaning if we evaluate it like we just did here, okay, then the whatever we receive as our answer is going to be our remainder. So we just pretty much prove that, okay? Now, to answer your question, you can do either one. For example, if you're being told to evaluate, you can do it, okay? If you are told to divide, you can divide using synthetic division. But this remainder is going to be important when we look and try to determine what factors of an actual polynomial is, okay? So just kind of keep this theorem in the front of your mind, okay? All right. So let's look at what we're saying here, okay? So here we're being asked to find the quotient and the remainder, which is what we've been doing, okay? So let's get a little bit more practice with this one. So example 3 says to do exactly what we did, use synthetic division, and we're gonna find the quotient and the remainder. So we have 2x cubed plus 7x squared minus 5 is divided by x plus 3. Okay, so what's our first step? Good. Even before that though. Good. Are we missing anything? What are we missing? X. All right. So we're going to rewrite this and put 0 in as a placeholder for that x. So this is going to become 2x cubed plus 7x squared. We're missing that x. So plus 0x minus 5 divided by x plus 3. Okay. So if we set x plus 3 equal to 0 and solve it, we get x is equal to -3. Good. So we take -3, put it on the outside. And what goes on the inside? 2, 7, 0, -5. We okay with that, guys? Okay, take a moment and do it. All right. Let's see if we all got the same answer. So you should have gotten as your quotient 2x squared plus x minus 3. And your remainder is 4. Okay, questions? All right, good job. All right, so with example 4, says to use synthetic division to find the function value and then check your work using a graphing calculator. So this is what you were asking, okay? So if it said evaluate, then you would just plug in. But because it says use synthetic division to find the function value, then this is where you need to understand that whatever my remainder is my function value, okay? So that means you're going to do synthetic division again. Are we missing any variables? Okay, we good? So then we put -2 on the outside. What goes on the inside? 7, -12, and -3. And we start our process. Okay, when you think you have an answer, you can look up here. How do we do? Good? Okay. So here we were simply looking for this function value, so that's our remainder. So that means if we were to take -2 and substitute it in, then our answer would be +41. And that's how you use the remainder theorem. Okay. All right. So I think we have the hang of that. So let's just kind of walk through this one. So here, again, it says given the function, f of x is equal to x cubed plus 7x squared minus 12x minus 3, we find f of 1. So here we have all of our exponents accounted for. 1 goes on the outside, and we bring our our coefficients down. We drop the first number, so 1 times 1 is 1. 7 plus 1 is 8. 1 times 8 is 8. -12 and 8 is -4. And then 1 times -4 is -4. We combine, and so we get -7. So that means f of 1 is -7. Again, if we were to take 1 and substitute it into our function, we would get -7. Questions? All right. All right, so we talked about the remainder theorem, okay? There is another theorem that gives us some key information as well. So the factor theorem simply says, if we have a polynomial that is a factor, then it is also a zero of our polynomial. So let me go back and explain that. So if we're given this function here, f of x is equal to x minus 3 times x plus 4 times x minus 7, then we know that the zeros of this function are 3, -4, and 7. Where are these coming from? Yep. Good. So that we're setting each one equal to 0 and solving for x. Okay, so that's where these zeros are coming from. That also means, using our factor theorem, if x minus 3 is a factor, then when we set it equal to 0 and solve it, 3 is a 0. And that's very important to understand. These are related, okay? Questions? All right, so let's look at example 5. So example 5 gives us a function. So we have f of x is equal to 3x to the third power plus 11x squared minus 2x plus 8. And then we have to determine if -4 and 2 are zeros. Okay? All right, so to do that, we can take our -4 and complete synthetic division with it. So we'll have 3. Well, let me back up. Are all of our exponents accounted for? All right. So we have 3, 11, -2, and +8. Right? Take a minute and do it. All right, is -4 a 0? Yes, good. Because the remainder is 0. That tells us -4 is a 0. And don't get these confused. This is actually, let's make it this, because the remainder is 0, then -4 is a 0. Okay? All right, take a minute and determine if 2 is a 0. All right, did you all get 2 to be a 0? No. So when we did synthetic division with 2, we got the remainder to be 72. 2 is not a 0 because this remainder is not 0. Okay? All right, so let's connect all of this together. This is where it should all make sense. So if you remember, the first thing we did with this unit over polynomial functions, we talked about what the graph would look like. Remember, it's smooth and continuous, okay? So here's the graph of a polynomial function. That function is y is equal to x to the third power plus 2x squared minus 5x minus 6. That's the function. When we graph it, it looks like this. Let's look at the function in terms of its factors. So that means if we were to put this in factored form, it would be x minus 2 times x plus 3 times x plus 1, okay? What do these factors have to do with this function graph?
Where they cross the x-axis.
Exactly. So here we get a 0 of 2, crosses the x-axis at 2. Here we get a 0 of -3, 1, 2, crosses the x-axis at -3. And then the final 0 is 1. And I'm sorry, the final 0 is -1, and it crosses at -1. Okay? That's the connection that we want you to see. So here, -3 is a 0. F of -3 is 0. So that means if we were to take -3 and plug it in, the remainder is 0. Therefore, our answer is 0. We've already talked about -3, 0 being the x-intercept. And so that is the connection that I want to make sure that you understand. Any questions? No? Okay. All right.